Fog may seem like ordinary water hanging close to the ground, but new research suggests it could be doing something we rarely consider. What if those tiny droplets are not as empty as they look? And what if a foggy morning is hiding a small biological process that affects the air around us? Scientists studying fog found something active inside it, something that raises new questions about pollution, microbes, and life in the atmosphere. In this video, we will explore what researchers found inside fog, why it matters, and what it could change. Let's get started. The study began with a simple question, but the answer was not obvious. When bacteria are found in fog, are they only passing through, or is something more active happening inside those droplets? To investigate this, researchers focused on radiation fog in Pennsylvania. This is the kind of fog that often forms overnight when the ground cools and the air near the surface becomes saturated. It was an important choice because radiation fog usually appears under calm conditions. With less wind involved, scientists could better study what was happening locally before, during, and after the fog formed. They collected fog water across multiple events and compared it with nearby air samples. At first, the result may sound expected. Bacteria were present in the fog, but that alone was not the real finding. Microbes are already known to exist in the air, carried by dust, soil, plants, water droplets, and other particles. The more important detail was what the bacteria seemed to be doing. Under the microscope, some bacteria in the fog droplets showed signs linked to active growth and division. That suggested the droplets were not just trapping microbes like passive cargo. For at least some bacteria, the droplets may have offered enough liquid water to become temporarily active. One group stood out clearly: methylobacterium. These bacteria appeared strongly in the fog samples, and their presence raised a deeper question. Were they simply surviving until the fog disappeared, or were they using the fog environment in a way that could change the chemistry around them? That question is where the discovery becomes more than a strange detail about mist. It points toward fog as a short-lived environment where water, air, and microbial life briefly meet. The reason this finding matters is that it challenges a simple assumption about the air. We often think of the atmosphere as a space that moves microbes from one place to another. A bacterium may rise from soil, travel through dust or droplets, and eventually land somewhere else. In that view, the air is mostly a transport route, but this study suggests that under certain conditions, the atmosphere may briefly become a place where microbial activity actually happens. The key lies in the fog droplets. For a microbe suspended in dry air, conditions can be harsh. Water is limited, exposure is high, and metabolism may slow down. But once fog forms, that same microbe may suddenly be surrounded by liquid water. Even if the droplet is tiny, it can create a temporary habitat. This does not mean fog is alive as one organism. The better way to understand it is that some fog droplets may host active life for a limited time. That distinction is important. The fog itself is still a weather event, but inside it, biological processes may be taking place. The strongest scientific clue comes from methylobacterium. This group is known for interacting with simple carbon compounds, and in this study, it became important because of its connection to formaldehyde. Formaldehyde is part of atmospheric pollution chemistry, and the bacteria appeared capable of breaking it down inside fog droplets. That turns the discovery from biology into atmospheric chemistry. If microbes inside fog can transform compounds in the air, then fog is not only a physical process. It may also be a temporary chemical system shaped partly by life. Still, the full scale of this effect remains unclear. The finding opens the door, but it does not yet tell us how much these bacteria change the atmosphere in real-world conditions. The first implication is air quality, but it needs to be understood carefully. If bacteria inside fog droplets can break down formaldehyde, then microbial life may contribute to the transformation of some pollutants. That does not mean fog can clean polluted air in a simple or dramatic way. The effect may be small, local, and dependent on temperature, humidity, pollution levels, and the type of microbes present. But even a small effect can matter scientifically if it has been missing from atmospheric models. Many models focus on gases, sunlight, particles, and chemical reactions. This research suggests that biology may also need a place in that picture, especially during fog events. The second implication is fog harvesting. In some dry regions, fog is collected as a water source using nets or special surfaces. If fog water contains active microbial communities, then it should not automatically be treated as sterile just because it comes from the air. It may still be useful, but like other natural water sources, it may require testing, filtration, or purification before drinking. The third implication reaches beyond Earth, but this is where the answer must remain open. Some scientists have long debated whether atmospheric droplets on other planets, especially in the clouds of Venus, could ever support microbial life. Venus is extremely hostile at the surface, but parts of its cloud layer have conditions that keep astrobiologists interested. This fog study does not prove anything about life on Venus. It does not show that alien clouds are inhabited, and it does not mean Earth bacteria could survive there. But it does show something important on Earth. Tiny atmospheric droplets can briefly support active microbial life, and that may be the most interesting takeaway. The air is not always just empty space between ecosystems. Under the right conditions, it may briefly become part of one. The next step is to test whether this happens in other places. Scientists need to study coastal fog, mountain fog, urban fog, polluted fog, and fog in different climates. They also need to measure how much chemical change these bacteria actually produce at atmospheric scale. Only then will we know whether this is a small biological curiosity or a missing piece in how we understand fog, pollution, and the living atmosphere. A foggy morning may look quiet, but this research suggests something active may be happening inside it. Some droplets could briefly become tiny habitats where bacteria interact with the air around them. So, if fog can become a temporary home for life, where else could life be hiding above us?